Hey y'all, want to check in with you about these identities, and hopefully you are kind of starting to see how these things work, and we're going to try our best just to keep rolling. And even though I can't be there with you, I'm going to try my best to stay in touch with you and to help you go through these. And Mr. Brown should also be close by, we hope. And if he is unavailable, then I know that Miss Scott and Coach Griffin are very well versed in all things math, so you should be able to find them. And even Miss Davidson, who is right across the hall, should be able to help you as well. So don't hesitate to reach out for somebody for help. And then also just, you can email me. We'll try to Google Meet and do some different things. But anyway, let's see if we can get through a couple of these. We did talk about some identities yesterday, and we really just wrote down all these tools for our toolbox and talked about how we need to simplify these things. Trig identities do have their place. For right now, we don't really know what to do with them. We just kind of have to get used to them and figure out how they work. So we worked through these examples yesterday, and I wanted to give you a few more that are a little bit more difficult, things that I don't really think you'll be able to figure out yourself, but definitely with a little bit of guidance, you should feel pretty good at afterwards. So, this one right here, we're still just trying to simplify these identities, and I noticed that we have a 1 minus sine squared. This reminds me of the Pythagorean theorem identities. Excuse me, just the Pythagorean identities. And this is what it looks like. You've got a sine squared plus cosine squared equals 1. And we talked about how you can rearrange these identities. You kind of can get creative and rearrange them so that you can get the version of the identity you need so you can replace it with something else. So, what I'm trying to say is, if we were to subtract sine squared from both sides of this equation, we would have 1 minus sine squared theta. And what would that be equal to? Just cosine squared. So the goal is to replace 1 minus sine squared with something that's not any more complicated, actually simpler. So that's what we're going to do, is we're going to replace this with cosine squared. I think this might be the same problem that we did yesterday, but I will do it again anyway. So we've done that, and then we are still left with the secant squared. Right now, there's a couple different ways that you could think through it when you get to this point. I prefer to honestly go back to the reciprocal identities and look at those. So here they are. You know that cosine is 1 over secant. And similarly, secant is 1 over cosine. Whichever one of those you decide to pick is fine. I think that I will change the secant squared, though, to be a 1 over cosine squared. And when you do that, you can simplify these because these two quantities will cancel and you're just left with 1. You don't always get a 1, but it sure seems to happen a good bit. Sometimes you'll have 1 and a little bit left over, but in that one it is just a 1. All right, so moving on. This one is definitely different. We have moved on from just multiplying expressions. Now we've got a subtraction going on here, so that's going to come into play. I don't know anything we can do here except to replace this with a 1 over sine x. And I hope you figured out by now that x and theta, you treat those the same way. All right, now the hint over here says to convert everything to sines and cosines first. So that's what I'm going to do. I'm going to leave this cosine a cosine. Now I'm going to turn it into a fraction because I know what's about to happen. Cotangent is going to get turned into a fraction. Look on your your quotient identities, and you will see that cotangent is the same as cosine over sine. All right. So here's what we got. We replaced cosecant with 1 over sine. I brought down the minus sign. I left cosine as it was. And these two things right here are multiplied. So I'm multiplying cosine by cotangent. All right, now, what we want to do is clean up this little section right here, because there are two fractions there, and that just needs to be cleaned up. Okay, so let's bring down 1 over sine, and then let's multiply these two fractions. So when we multiply straight across. Cosine times a cosine is a cosine squared. All over 1 times sine is a sine. I'm feeling a little reminiscent of some algebra 2 when I get to this step, because we learn how to add and subtract rational expressions, and we're kind of to that point when we get here. We've got a fraction minus a fraction. And what do you notice about these fractions? Thank goodness they have the same denominator, right? So we don't have to worry about that. But we do need to combine them into one fraction. So if I do that, both fractions have a sign for a denominator, so write that there. Now on the top, we would have 1 minus cosine squared. That is just combining those two fractions into one fraction. Okay, just 1 minus cosine squared. Write that as the numerator. Now, what do you notice about this top part of your fraction? Doesn't it remind you of this Pythagorean identity we just used on the other example? It's because it comes from the same thing. And what we can do is use it as well. All right, so the way that we rewrote that first one, we can rewrite it by adjusting the other part if we need to get 1 minus cosine squared. So if we subtract cosine squared on both sides, all I'm really doing is just scooting it over to the other side of the equal sign. I'm left with sine squared equals 1 minus cosine squared. And that's what's on the top of our fraction over here. So we really do need that version of that Pythagorean identity. And then we can replace it with something simpler, which is just sine squared. Okay, I hope that's not too much of a leap for you, but there it is. And then on the bottom, we still have a sine x. We are almost done. So if you have sine squared, I'll do it like this for you. Isn't that just the same as sine times sine? Of course it is. All right, and then on the bottom, you just have a regular old sine. Now, it's a lot easier to see like this. So if I have a sine on the bottom and on the top, I can cancel those, and all we are left with is sine x. So that would be your simplified version. That is a pretty tough question, but honestly, that's my goal for you, is to be able to do one like that and to feel pretty good about it, okay? You can do that. Definitely, definitely, definitely. All right, I want to do this last one with you. I'm wondering if I'm going to have enough space, but we're going to try to work it in here. All right, notice here where it says factor out a common expression. This one is sometimes hard for people to see, but you are smart. You can do this. What do you notice about this part of the expression and this part? What do they both have? They both have a sine squared. So what we can do is we can factor that thing out, meaning we can figure out what happens when we factor it out, when we eliminate that from those terms. What are we going to get? All right, that's what we want to figure out. I'm trying to get rid of my chicken scratch here. It looks terrible. Oh, goody. Now we're having a meltdown in Word. That's so much fun, isn't it? Oh. Let me pause for a second, see if I can rein this thing back in. Okay, y'all, I am not being very successful in getting this to cooperate. So I'm going to stop this video, and then I will do you a fresh new one with that last example.